You run uptime and see three numbers staring back at you: load average, 1.34, 1.12, 0.98. They look like floating point math, but they are actually one of the most useful health signals on any Linux system. Load average counts two kinds of processes: those sitting in the run queue ready to use the CPU, and those stuck in uninterruptible sleep, labeled D, almost always waiting on disk I/O. Think of it as two queues, one at a coffee counter for the baristas, another at a bakery counter for the oven. Both lines add to your load. These two queues come from very different kinds of work. CPU-bound load means processes are actively hungry for processor cycles. Imagine workers at a desk piled high with paperwork, all waiting for a single pen. I/O-bound load means processes are stuck in D state waiting for the disk to respond. Picture people staring at a locked door, keys turning slowly on the other side. Both kinds count because both kinds cost you a core. A CPU-bound process is burning cycles, so that core cannot do anything else. A D-state process is also holding a core hostage. The kernel cannot schedule anything else onto that slot until the disk call returns. Load measures demand for cores, not just CPU usage. Here is the golden rule. Load average only makes sense relative to your core count. On a 4-core box, a load of 4.00 means full utilization with zero headroom. A load of 8.00 means twice as much work as your machine can handle. Processes are queuing, response times are climbing, and your system is in trouble. Here is a quick heuristic per core. Under 1.0, you are healthy with room to spare. Right around 1.0, you are fully utilized but fine. Above 1.0, you are saturated. Well above the number of cores, processes are visibly waiting and users will feel it. The three numbers are an exponentially damped moving average over 1, 5, and 15 minutes, and together they tell you the trend. If the 1-minute number is higher than the 5, which is higher than the 15, load is rising. You are heading into trouble. If 1 is lower than 5, which is lower than 15, load is falling, pressure is easing. Load average is not CPU percent. You can have a load of 0.30 while one process pins a core at 100%, because that one busy process does not move the average much. You can also have a load of 20 with mostly idle cores, because 20 processes are stacked up waiting on disk. The number reflects demand, not utilization. One last caveat: because D-state processes inflate the load, a number above your core count does not always mean you need more CPU. Check PS for D-state processes, inspect your disk weight metrics, and look at IOStat. Sometimes the cure is a faster disk or a different storage driver, not another processor. We start with a clean Linux terminal, ready to inspect our system's CPU health. The goal is to read the system's current load, count available CPU cores, compare a second reading for trend, and identify the processes consuming the most CPU time. We'll execute each command in sequence and read the output like a system operator would. First, we run clear to wipe the terminal buffer and start with a clean canvas. This isn't strictly necessary, but it makes every subsequent step's output easier to read and capture without visual noise from prior commands. Now we run uptime, which tells us exactly how long the system has been running, how many users are logged in, and the load average over the last 1, 5, and 15 minutes. The three numbers after load average represent the system's runnable queue depth. Values near or above your core count indicate a busy system. Here, the 1-minute load is 0.45, comfortably below capacity. We clear the screen again to isolate the next command's output, then run cat/proc/loadavg to read the kernel's raw load average file directly. This gives us the same three load numbers plus extra fields: the running /total process count after the slash, and the most recent process ID assigned by the kernel. It's the source of truth that uptime itself reads from. Next, nproc simply prints the number of processing units available to the current process, typically equal to your CPU core count. We compare this against the load average. A load of 0.45 on 8 cores means the system is essentially idle, with plenty of headroom. This number is your baseline for interpreting whether a load average is high or low. Now we rerun uptime to take a second reading and establish a trend. Comparing the two samples, the 1-minute load moved from 0.45 to 0.52 over a few seconds, and the 5-minute average stayed nearly flat at 0.62. When the 1-minute value is higher than the 5-minute, the load is rising. When it's lower, the load is falling. This is how you spot load changes in real time. Finally, we run ps eopid com%cpu sort equals %CPU head -6 to list the top 6 processes ranked by CPU consumption. The EO flag customizes the output columns to PID, command, and %CPU, and sort equals %CPU puts the heaviest consumers first. The pipe to head -6 trims the list to just the header plus the top 5 processes. A standard operator's one-liner for spotting what's burning CPU right now.